Dr. Dalogu, Assistant Professor of Psychology and Director of the Psychology Program here at Lawrence Tech, holds his PhD in Cognitive Psychology, extensive international experience in teaching and research in the areas that are relevant to cognitive psychology and neuroscience. Here's where I'm going to mess it up. Postdoctoral research activities at University of Rome, Italy, that one's easy, the Riken Brain Institute in Tokyo, Japan, University of Utrecht in the Netherlands, the Chinese Academy of Science in Beijing, China, and he has also authored more than 30 peer-reviewed publications in the fields of multisensory perception, spatial cognition, working memory, music processing, language acquisition. In addition, he's a really good person to work with. I've known him for 3 years. He's very dedicated and tireless. He's a really proud husband and father and just good people all around. So.
Thanks. Oh, chairs. Please. Some more chairs. Okay. Good afternoon, everybody. I would like to start with a consideration. So, we experimental psychologists, we do this strange thing. We convince people to come to our labs to do strange things, like to count, to press buttons, to see images, to listen to sounds, to perform some really strange tasks, right? And we do that for a reason. We would like to understand human behavior and the structure of our mind, and sometimes the structure of our brain, right? And this kind of simulation of what happened in real life that we do inside of the labs, sometimes in rare cases can be achieved even without going into the labs, but just analyzing things that happen in real life. And a wonderful case is doing analysis of games, right? Because people like to game, like to play things, right? And this is one of these cases, right? This is the motivation of this study. We are doing an analysis of a game, right, to understand something about the mind. Okay, I would like to start with a short video. That's probably enough. Okay. Morra is a game, and I'm going to explain the rules now. Okay?
Is that what we just saw, the Morra game?
That's the Morra game, yes. It's I will explain the origins and everything in a little bit, but let's explain the rules as the first thing. So it's very, very simple rule. Who calls the sum of all displayed fingers scores a point. For example, now in this situation, is there a person that is going to win to score a point here? Good. Good job. What about here?
They both get point?
And this means that nobody gets the point, right? Both gets the point, so nobody gets the point. What about here? The one on my on your right scores a point, right? Now I need 2 volunteers now. Please. One.
You're a mathematician, you should be able to count.
But I'm terribly slow.
Another volunteer, Jamaica. Okay, now I will act as it's called the counter, the
Okay.
person that counts it.
Okay.
So at the same time, you shout the number like this gentleman did in the video,
Right.
and you show and you flash a
shout in
number.
English?
Okay, you can do it. Yes, just for this time. Then you have to learn Sardinian. Okay, try.
Okay,
Just one
we show
time.
the hand at the same time we shout, right? Same time?
Yeah.
Okay. Okay. 5.
4 and 4. You said 5. He said 5. You said 5.
We both said 5.
We both said 5.
Okay,
and
but
we
it's
both-
4 and 4. Nobody
no one
wins.
wins.
Again.
3.
5.
Do we keep
Yeah,
going?
sorry, I'm slow.
4.
4. I say back, I'm slow. Okay. 5.
Nope. 6.
6.
It's a 5.
4.
4. 5.
6.
5.
Oh,
got it.
we have a champion of Lawrence Tech, right? Thank you. Now, you see how difficult is this task, right? And, okay, in the mind of Chris and Jamaica, all this thing was going on in a very, very rapid time. So we have, let's say, not in their mind, but in the mind of the guy that here is winning the point, okay? This person is, okay, the premotor cortex says, oh, I want to flash a 2, and sending this message to the motor cortex. I'm recognizing a 4, right? Occipital cortex goes to the inferior temporal cortex. Say a 6, Broca area transmit information to the motor cortex again, just to say the 6. That's a very complicated stuff. But this is not what we are going to talk about today, because this is actually not very complicated for human beings. This is actually something that we do all the time, no problem in this. This is much more complex. So we're not only deciding what to flash and what to say, we are actually using the memory of what happened before in order to put a nice number in there, to win, to score a point, right? And this is very complicated. Many people believe that it's actually not possible because it's too complicated, okay? So this is the nature of this study, right? To use a game to understand the human nature, okay? Okay, this game is actually very old. This is a mural present in a tomb in Beni Hassan in Egypt, and is 4,500 years old, right? As reported in this book, that's a very nice book. Actually, I'm discovering very interesting things. It's published by, it's authored by a guy that's called Faulkner, and it's written in the 1902, right? And it's about the origin of different games, right? What it does is to report proofs of the origins of this game from these tombs in Beni Hassan, and this is a drawing, a light drawing of some of the murals made by Champollion, one of the greatest Egyptologists of all the times. And this hieroglyphic says, try to guess, something like that. This is the translation of this. After Egypt, the game moved to Greece. And this is a vase painting in which two ladies are playing for stakes that are represented, that are symbolized by these vases. And this rod that they held is something that is used to mark the points, because probably it was like marked with different points. So when you are winning, you drag the rod a little bit. And this is love, eros, that is always good. If there is love, there is everything, right? And okay, so this is Bartolomeo Pinelli's illustration, and it's about Morra and it's an illustration of the 1804, and this is a painting also of a Roman scene. Roman, not like the ancient Romans, but like in the 18th century Rome, in which people are playing Morra, and curiously enough, this is a policeman in Italy. It's a carabiniere, right? And you can see beverages, alcohol in there, and you can see alcohol in here, right? And it's interesting because stakes, wine, and aggressiveness made the game illegal for a lot of time, and officially still illegal in Italy, in public places. You cannot play this game. Oh, okay, but it's tolerated. There is nothing. They don't play for stakes anymore, right? So it's nothing is going to happen. But look at this. How interesting is this? This is actually taken from another place. This is not Sardinia. This is Spain. But you can see this nonverbal behavior here of people getting so excited by taking a point, right? By scoring. That is something that you can see in every part of the regions in which Morra is still played today. So I think it's very interesting from a social psychology perspective and from an anthropological perspective. Okay, Morra today is spread in 5 countries: Italy, Spain, France, Croatia, and Slovenia. Interestingly enough, there are several linguistic minorities involved. Very rarely is played in the official language of the country, but is played in the country of the place, in the language of the place, which means that is associated often with cultural identity and local traditions, right? For example, you can touch everything to a Sardinian person, but you don't touch Morra, because Morra is sacred in Sardinia, because we do that in Sardinian, right? It's very, very traditionally grounded, right? But also it's interesting to see that Morra is used as a bridge to connect minorities with this Morra Mundo initiative, which are these tournaments that involve different kinds of Morra players that meet in order to do to compete with the game of Morra. Okay.
Hey Franco, what's the link between Morra and Rochambeau?
What, I don't know what Rochambeau is.
Rock, paper, scissors.
Oh yeah, it's I think it's very much related. This is more mathematical. There is like there is a prevalent combination, right? If you have paper and the scissor is going to cut the paper, right? And then you have all reverse combinations. But here is purely combination of sums, right? It's more mathematically grounded, more grounded in probability. But many aspects are similar. We are going to talk about that later. Okay, so, and And I started this Morra project for several reasons. One of the main reasons is that the Morra is very interesting in the framework of the dual processing theories of the mind. Let me explain what I mean. Now, psychologists, many theorists believe that we have two minds. One mind is very fast, has a high capacity for information, works in parallel, is non-conscious, does have biased responses, is automatic, is associative, is independent of cognitive abilities, independent from cognitive abilities. Can you imagine that? And the other is slow, capacity limited, serial, conscious, normative responses are used, is abstract, is controlled, is rule-based, right? So it kind of goes close to mathematical reasoning, right? Very much. But Morra takes aspects from both sides. And this makes a good candidate to challenge the classical model of dual processing in the study of the mind, right? The second is social psychology and anthropology. I really would like to understand what's going on in the mind of a person that dominates the other for one single point and express that so loudly, right? There is no violence involved in that. Actually reminds me, you score something and you like football, American football, right? So there is the touchdown and then you take the ball and you do, something like that, right? This kind of feeling, but is directed completely against your opponent because you outsmarted him or her, right? Such an interesting aspect. The third thing, it's a provocation for my friends, mathematicians and physicists. It's about the non-Platonic numbers and the intuitive sense of probability. So this is a citation from Dehaene. It's a famous neuropsychologist. And it says, most mathematicians, overtly or covertly, are Platonists. They picture themselves as explorer of a continent of ideas independent of the human mind, older than life and immanent in the very structure of the universe. Right, George? There's no question about that, right? We will die tomorrow all, and the universe will still follow the laws of physics that are mathematical rules, right? No problems in that. Right, George? Yes. But now, people, we don't have to forget that the only instrument that we have to understand numbers is our mind, right? Then you really like to go up north, you Michiganders, you really like to go up north and you take the Mackinac Bridge, and this bridge is supported by a structure that was done by human minds using numbers. It's not abstract numbers. It's numbers that are used and understood by persons. If the calculation is wrong, because it's made by a person, this bridge is going to collapse, and you cannot do your wonderful vacations up north, right? Second thing is chickens can count and distinguish 2 from 3. So it's not only the human mind that has a sense of number, but many other, at least mammals and birds can do that, right? So it's a different perspective about numbers, is to understand how the mind digests and processes numbers, right? This is my way of saying non-Platonic numbers, right? And also, related to this, there is evidence that finger-based strategies play an important role in learning and understanding arithmetic. There are many studies that, when you are educating children to do mathematics, if they count with hands, this is very, very nice for their mathematical mind. So, processing mathematical information with hands is good. The fourth reason is that this is really sexy, methodologically speaking. It's incredible that we, for one time, we have numbers already there instead of translating the behavior or feelings or emotions or whatever into numbers. We psychologists do that all the time. We translate behavior into numbers, but this behavior is already numbers, right? For example, when you see a game, you have an A hand and an A voice, and then you have a B hand and a B voice, and you can just analyze what's going on in there. You don't have to do anything. The numbers are there. Fantastic. Methodologically sexy, right? And the fifth reason is the most important. No, it's not the most important, but it's important too. It's just the homesickness of a Sardinian mind. So it's like very, very nice for me to do a study that involves so much my cultural identity. Okay, let's describe the state of the project. We have done something, we are working on something else, and we have future work in to do. Now, we did a literature review, and we did a naturalistic observation of Morra. We took data from the field, let's say. What we are doing now is tabulate, right? Fate. We are tabulating audiovisual and electrophysiological records into quantitative data, right? And it's a very long and tedious process. I'm going to show you how it's done. We are starting already with the data that we already tabulated. We are starting a behavioral and electrophysiological analysis, and we started to do a model of optimal strategies to win in the game. If you were not a human being, that is probably limited. How do you play, right? The future work is inferences about the type of cognitive processing involved, preferred strategies, probability estimation. Develop an algorithm that implement an optical game strategy in real time. And then, this is really sexy again, design a robot to play the game against humans in a naturalistic setting. And you would say, oh, this is strange, but look at this. I hope this is going to work. The thing exists already, so we can compete against this computer. It's Lawrence Tech. Oh, it's not there. Wait. This is called Gavin 2. This was developed by high school students with the assistance of a professor of computer science. It's pretty amazing. Oh, yeah. Okay.
That's in Italy, right?
That's in Sardinia, yes.
Why Sardinia?
Sorry, why Sardinia? Because you can study that also in Spain or in other places, but it's easier for me because
No, I mean, did your research reveal that there is some cultural or anthropological mechanism behind the regions where the game is played?
No, that's a very good question. And this is not, you are going to see now the team is very differentiated in terms of competences. This is really not my strength, but it's an excellent,
But
yeah.
if you think that the game is more complicated than rock, paper, scissors, where's rock, paper, scissors played? United States and England? So maybe we're not quite as smart as the Europeans.
I don't know.
Sardinia was dominated by the Moors a long time ago, so maybe that's
Sure.
one possible lake. I guess I am Sardinian too.
You're biased. You can't use it.
I don't know, but this is an excellent question. Why Sardinia? Why in Sardinia is so strong? Why survived in Sardinia and not in Rome, for example? And so it's very important also dissemination in the fields of the dual process of theory of mind, number sense, historical, anthropological, and social aspect of the Morra game, right? So the Morra team is a big team. Involves many people at Lawrence Tech. It involves people that are actually in Sardinia, in a small town, which is my hometown. And many friends helped in this process, and it's just really, really interesting to see how people are interested in that. For example, we got like 4 or 5 papers in the newspapers, like talking about what we're doing. people are really, really interested in that in Sardinia. It's very important culturally. And then we have the University of Cagliari, in which almost all the tabulation is going on, because we have, and actually I said Lawrence Tech, but we have in a high school. What's the name of the high school?
University High School Academy.
University High School Academy with Peyton and Tracy. They are working on tabulating the data in Sardinian, right, from Sardinian to numbers. So, and I want to thank and say hello to Carla Meloni and Rachele Fanari and all the students that are working in Cagliari about this. Hey! And just thank to everybody. But also Daniel Moscoso is working on a very complicated project. We're going to show some data about that. And Kyle Novak is a student that is working together with George Moscelli. Had to leave because he has class. And there is there anybody from the math club here? No.
Math club?
Yeah, because the other day. Are you?
He's a math major.
Oh, that's interesting. I didn't know that. He's a student of mine in introductory psychology class. That's good. Good to know. So, all these people are trying to understand the mathematical features of this game, right? So thanks to everybody. Now, let's talk about the field study. To record data in a controlled fashion, we organized the Morra Tournament in Bitti, which is a small town in Barbagia, which is a region of Sardinia, a very traditional part of Sardinia. And what we have done is to organize a tournament that is structured in this way. There are 16 champions from different Sardinian towns come to visit in Bitti, and they will play a pair against another pair in 4 different tables. The winners go to the semi-final, and the winner of the semi-final go to the final, right? Now, the structure of each table is organized in this way. You have a pair on one side, a pair on the right side. One of the champions is equipped with a Mayo EMG recorder that you can see now in a video, and I'm going to explain what this machine is doing. But the recordings are made from above, so we can see the hands and we can record the voices of the players. Now, here is an example. Okay, you can see there, that's the Mayo EMG recorder. It's actually recording the activation of the muscle or bundles in the arm, right? Which is a way to understand which number is going to be said. And it's recording wirelessly. This is me explaining the rules. Well, not the rules of the game. Obviously, they know much, much better than me. These are champions. They are probably the best people that I can find in Sardinia. Okay.
So I think you can tell from this who's winning, right?
Now, every time, okay, let me explain. This is a good question. Every time that you score a point, you go and play against the other, right? So you do this, you play, you win, and you play against the other. When you lose, you wait and you watch the others playing in order to understand the strategy of your opponents, right? That's more or less what happens. Now, how can I? Oh, yeah. No? Alt tab. Oh, good. Oh, yeah. Now, that's the importance of the counter. It's a very, very noisy game, right? But not only in terms, in mathematical terms. It's noisy because the structure of your end configuration can be ambiguous. Actually, sometimes they try to cheat on that, and it's really bad, right? If you are not controlled, it can be really it can be aggressive, the reaction of your opponent, right? But another thing is that you can slow down and see the numbers before and change. And we are going to analyze that with the Mayo recordings, for example. So the procedure of this study was we did 5 minutes of preliminary interview with the demographic data, 20 minutes of each match, 3 games. Like you don't win all the match with 1 game. You have to win at least 2 of the 3 games, right? And then if you win, you go to another match. Then there is every time that you do a match, there is a post-match interview. And then at the end, when you finish to play, you do a final interview with strategies and things and comments, okay? Now, about the surveys, immediately after the game, you are asked what are the numbers that you play the most. This is the number that you play the most. This is the second, and this is the least that you played, right? And the same thing about the configurations of the numbers that you said. You can say 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? You cannot say 1 because 1 doesn't sum up with anything because 0 doesn't exist, right? Okay, so you have 9 combinations for 9, an order of 9 most played, most said numbers, and an order of 5 most showed more flashed numbers, right? Now, this is the part that is really interesting. Now, I'm going to show you some very preliminary results, but I'm really excited about the directions in which the study is going. And I'm going to talk about frequency analysis, electrophysiology, indication from the interviews. Now, what numbers do people flash more often? Now, it's very important. If you think about this game, it's very important to be unpredictable, right? And it's important to be as random as you can when you play this game, right? So in an entire game, if you're a perfect player, right, you should play each one, you should show each one of the 5 fingers in a more or less the same amount of times, right? So let's say you show 100 numbers, you will show 120 times 1, 20 times 2, 20 times 3, right? 20% of the times per each finger combination. Are you with me? Okay, great. Great. Oh, this is what happened, right? This is actually the proportion of flash numbers in, it's not all because we are still tabulating some data, but until now, we can say that you see people generally played the 20% of each number. This is 1, 2, 3, 4, and 5, and they played more or less 20%. But this is a cumulative data, right? They are all the data together. If you look at the standard deviations here, they are pretty high. It means that there is some variation in it. Please.
What they said, or is that what you...
Flash.
No. Where did you get the data? According to what they said, or according to what you saw?
What they flashed, what they showed with the hands.
What they thought.
No. This is actual data.
Okay.
This is taken from the video recordings. Good question. Yeah. But if you see the behavior of single people, right, it's not so clearly all around the 20%, right? There are some preferences. right? For example, let's say this person played 1, 2, 3, 4, 30% of his total of hands, right? 30% is a dangerous, unbalanced distribution. Because if you play a lot of 4s, I can get you, right? So it's better not for you not to play so often. 30%, it's a lot. Now, for example, if we play now with no experience, these are champions, okay? If we play with no experience, we probably do the 50, 60% of 4s, right? But 30% it's already a lot, okay? Now, this is an analysis that I did only with one player, right? And I think it's very interesting. Now, it's the sequences of 2, okay? So for example, if I play a 1 and after a 1 I play a 4, that's a sequence of 2. It's 1 and then 4, right? I can do 1 and then 3, which is a different combination, right? Now, with 5 numbers, you have a total of 25 possible combinations, right? You have 1 with 1, 1 with 2, 1 with 3, 1 with 4, 1 with 5, 2 with 1, etc., right? 25 combinations. Okay, you expect, if you don't have a repetition of patterns, right? If you don't have a repetition of pattern, to distribute these sequences of 2 equally, right? I play as much as I play 4, 5, I play 5 and 4. And then I play 2 and 3 as much as I play 4 and 1, right? Okay, so if you do, for example, let's suppose that you play 395 pairs. You divide by the number of combinations. You have the number of times that you should play each one of the sequences to be perceived as random, right? And not to be too predictable. Because if you play 1 and 4, 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 and then I see that you are playing a 1, oh, it's going to play a 4, and I do 6, and I get you, right? Because 6, 2 plus 4 is 6, right? So in order to be unpredictable, you don't have to do 1 and 4, 1 and 4, right? You have to play all the 25 sequences equally in terms of distribution of probability, right? Now, this is probably one of the best players in Sardinia, okay? He won a lot of tournaments, and he played at least 150 tournaments in his life, okay? Do you want to see the distribution of times that he played one or the other combination? This one. I think it's crazy, right? So he played the sequence 4-2 62 times. This is the amount of times that you should play in order to be random, which is 15.8, right? So it's absolutely clear here that we have a pattern. And this goes back to the theories of how our mind work, right? We cannot avoid pattern repetition. Right? This is a comment that I really love by one of the players in the interviews. Sometimes I try to change. I say to myself, do not flash a 2, otherwise it will score. But it's a habit. You show it anyway. You need a lot of training. I show 2 and they score. With them, with a game that just finished, with them I was thinking, if I show a 2, they will score. But to change is not easy. It's really interesting how the conscious mind is fighting the habit of repeating a pattern here, right? He's a very good player and still cannot control himself. This leads me to this kind of analysis. There is a lot of literature about random generation task, which is a task that is used to investigate the central executive component of working memory. Now, just in a few words, working memory is our, let's say, short-term memory and controls what we have in mind in this moment. You probably, in your working memory now, you have what I'm saying, right? Because you are paying attention to to what I'm saying, right? And the executive control is not the contents, but the direction of your attention towards certain things, right? To change task, to control, to find control what you are doing, right? Now, this task is very interesting. You just have to generate numbers. It's very similar to Morra game, if you want, right? And you have to say like 2, 6, 1, 9, 1, 4, 2, 3, 9. You see, 2, 3, 9. I said it 2 times in just a little moment, right? It's very difficult to control the seriality of our behavior. It's like we have an internal clock that doesn't work very well. It's not random at all, right? Okay, now in these kind of studies, there is a lot of literature about this. Randomness values are very low, meaning that people cannot be random, like in Morra. Pattern repetition is frequent, and random generation tasks can predict clinical conditions. Now, I already said healthy people are already bad in the task, but Alzheimer people, people with Alzheimer, people with schizophrenia, and people with frontal lesions, they do horribly in the task. They cannot really, they are really repetitive, more than the normal subjects. So you can see that if this is used, okay, let's say in this way, we have a lot of interesting literature that we can base our study upon, right? Because this is not a new problem in psychology. So I'm really pleased that we can use, for example, this kind of analysis. I'm not going to go into the details of it, to analyze the Morra game, right? Like this paper analyzing humanly generated random number sequences, a pattern-based approach. It's a recent paper with a very nice way of analyzing the patterns in a random generation task. So we can apply that technique into the Morra analysis. Now I show you this, what is the best number to call? But then I go immediately away because I would like you to guess. What's the best number to call, to say with your voice? Is there a best number? Is there a worst number? You remember that my number, the flash number, plus your number is going to be the sum that I have to say with my voice in order to win, right? Is there a best number?
6 or?
Why 6?
I don't know. It just sounds like a good combination between 2, 5.
Okay, let's say in another way. If the other guy shows a 5 and says Morra, it says 10. How many combinations are possible with a 10? If you say a 10. Only one. Very good. Okay, if you say 9.
2.
Which one?
5 and 4, 6 and 3.
5, 4, and 4, 5.
Oh, excuse me.
5 and 4 and 4 and 5.
600 people play.
Right? What about? Because we have a limitation of hands, right? What about if you show a 3? If you say 3.
That's right.
Right, and just that, right? 3 and 0 doesn't exist. What about 2? Very good. Now, look at elegant is this. Now, with 10 and 2, you can win only with one combination, 5 and 5 and 1 and 1. With 9 and 3, you can win with 4 and 5, 5 and 4, 1 and 2, 2 and 1. With 4, you have 3 combinations. With 5, 4 combinations. With 6, 5 combinations. So 5 is a better number to be played, right? Because you have more possibilities to get the other. Because you have more combinations that are possible in a random planet, right? But we are saying that we are not so random. Okay, let's do the analysis. This is like a model, right? Let's overlap with real data, like taken from the video recordings. This is what happened. Astonishing, eh? This is the actual number of times that they played, that they said the word 2, 3, 4, 5, 6, 7, 8, 9, and 10. It really overlaps very well with the theoretical distribution of probabilities that they should have if they would be random, right? I think this is a very interesting combination. Still, if you go and look some of the players, please.
In a way, you're kind of demystifying the game, right? You know, so you're kind of exposing it, right? The how you can win that. Right? So what's going to happen to the game? Isn't that what academics do?
It's so fascinating that I don't think that this is going to change a comma, because it's impossible to be, you can pay more attention. They already know, some of them, they know exactly what is their problem. Like, I want to change, I don't have to flash a 2, I don't want to flash a 2, boom, 2. You know, there's the difference between the two processing, right? The conscious, controlled mind and what you are like forced to do by the fact that we have limited capacities in our cognition. I think it's really fascinating. Wait, now there is nothing, there is an interview that says, playing the 6 is too easy. I really don't like to win in this way. I like to win with saying 10 and saying 2. Because when you say a 2 and you win, it's demonstrated there is no random in there. I just over-smarted you. Right? So there are these actual social components into it. Actually, just to say another thing, just to, many factors complicated these calculations. There was a guy that now died, unfortunately, and it's very famous for his performances in Morra that they report, I never know, I never met him, but they reported me that he did this. 7, 9, 8, 6, without changing the number, just keeping the hand like this. And then when they finally got the fact that it was always a 5, he changed 2 and a 1. So, you know, that's astonishing, right? The control there is astonishing, and how you are brave to challenge the other in order to demonstrate how smarter you are than your opponent, right?
I guess one of the most important things as well is, okay, because women don't play this game, it's just a man. So I played a few times with him and other people, but for me it's really difficult. I understand the game, but I can't play it. So to me, the most difficult thing is not playing just the one number, it's guessing what he's going to play and trying next. So it's the next move that you're thinking about, not just the amount of times that you play a certain number. It's not to repeat the pattern and to understand the opponent's pattern. So that's the most.
Yeah.
Yeah, I don't know.
That's absolutely true. People try to understand the others. People try not to discover themselves at the same time, right? And talking about what Julia mentioned now, I would like just to go and see a little bit of strategies. This is again, this is the guy that won the tournament, right? One of the two guys that won the tournament. Now, what is, I'm going to talk a little bit about Morra puntata, which is the targeted Morra. Is the awareness of the most frequent flashed numbers by each of your opponents. Let's suppose that I play a lot of 4s, right? And my friend plays a lot of 3s, right? My opponent should change the strategy in playing against me and against my opponent, right? And in which way? Isn't exactly in this way. Your voice minus your flash number is the targeted number. So, for example, if I'm expecting you to play a 3, I would say 7, right? I would say 5, right? I'm targeting your 3. Why? Because you played a lot of 3s before, right? how complicated and how big in terms of working memory is this task. It's astonishing, right? But let's see Leone. Leone is probably surely in the tournament, one of the best players, but he wins a lot and he plays a lot. Now, he's playing in this game against Garau and Moredu. Moredu plays 11% of times 1, 35% of 2, 14% of 3, 27% of 4, and 14% of 5, right? And Moredu is very different. He almost never plays a 1, a 2, 20%, 3, 4, and 5. Oh, look at the 5. 42% of 5. A lot of 5s, right? If I would be Leone, I would do my voice minus my flash number in order to get a 5 there. So I would play, for example, 6, and then I will play 7, and then I will play 8. Are you following me? I'm getting always to the sum of to get your 5, right? Look at what he did. This is Leone's voice minus hand, which means what is targeting. He targeted the 11. He targeted the 1 exactly in the same amount of the same amount of times that actually Garau showed, right? But and look, the highest percentages are here, 33 and 28. That is consistent with the highest percentages in here, right? It's not perfect because you have a 28% also here, but still, it's really interesting. And but this is very interesting. Oh, this is inverted. Sorry, this is on Moredu. Okay, 35% here is targeting the 5, which is played 42% of the times, right? Is evident that he's targeting the numbers that are that are more frequently played by his opponents, both in a separated fashion, right? Now, if you run a correlation about this and this distribution, I know there is no sense about doing that because there's only 5 numbers, but you will get 63% of the Garau target and between the Garau target and Garau hand, and the 73% between Garau. Sorry. Wait. I think there is a messed up here thing. Garau target. Yeah, the names are inverted. So the thing is, when you change, let's suppose that you would change the hands, the target numbers of Leone, inverting the 2 opponents, he would do a disaster, right? So he's really targeting the numbers that he's seeing the most in the hands of the opponents. Okay. Here, I just want to say something about the strategies that they reported. This is an interview. For example, one flashes a 3 and says a 7, right? He's probably expecting you to flash a 4. Do you understand? Then flashes a 2 and says a 6, right? Let's see that. 7 with a 3. It means that he's targeting which number? 4. A 4, right? Perfect. And what about here? 4 again. When a person is playing this, you understand that he's targeting your 4, and what you do, you don't play a 4 anymore. That's really advanced. This is one of the few people that told me that he listens to the person because he has the time, I don't know how, to understand this subtraction and try to avoid the targeted number, right? So voice minus hand is equal to 4 all the time. So do not play 4. Do not play 4. This is the instruction. Please.
So you mentioned that people have tendencies for which numbers they flash more often than they should.
Yeah.
And you also said that people are pretty good, at least the best players, at anticipating the numbers of the other person.
Yes.
I wonder if people also have tendencies in terms of what numbers they expect from other people in a way that might be irrational. So some people might expect the number 4 across the board more often than they should.
Okay. There are contrasting responses to what you are saying. In one of the interviews, there is a person that said, when a person plays 4, 5, 4, 5, 4, 5, it will always play a 2. I can bet on it. He said that I was, oh, really? Everybody? Yes, everybody. He said something like that. Okay. But I don't think, I don't see any reasons why our minds will coordinate on a certain sequence that is universal. Right. So I would believe that we fall into repetition patterns, but the patterns can be different. But he said that. It's kind of interesting, right?
I was saying it would be irrational to universally expect.
Yeah, it's irrational, yeah. But he has this magic thinking.
Yeah.
Okay.
Can I ask a question?
Please.
Regarding the hand voice, is there research on handedness?
Like left-handed, right-handed?
No, there is no.
I would think, like, you know, in a similar vein that, you know, what Stroop taught us about familiarity with, you know, words over color, over naming, colors over naming colors, that there might be something here to consider.
It's interesting. I think training can do everything, and the task is very simple. It's not like playing piano, right? Or writing, right? Actually, it's the same. Let's suppose that you write with your left hand for a lot of time, so you will have you will develop a sense of.
I just think it's an empirical question because I would.
So,
I think
let me think. I think that people will get used to it because for all their life they are not allowed. Can you play against me, please?
Yes.
So if I play like this is kind of weird. So it's you know, there is this actually axe.
No, go back. So my comment is about,
Thanks.
Again, what Stroop taught us, that in a dual task,
Mm-hmm.
that with the Stroop effect, the reason why there is this
Because you are forced to read the number, right?
So if you
To read
switch
the
hand, you're forcing more energy of your mind to go to the non-dominant hand, and it would be interesting to find out what happens.
I'm not completely sure if I understand, but we can talk.
Players playing with their left hand.
Yeah, right-handed players play
Yes,
with
but
their left hand, left-handed players doing the right hand. And does handedness then free up your mind a little bit more to do some of this decision-making?
Are you allowed to choose?
Why? You know, I would say that when you are using the well-known road, right, you need less attentional resources than using a different way, right?
Yeah, exactly.
Okay.
That's my point.
No, that's the contrary of your point, because you are saying if I change hand, you have an advantage. I have a disadvantage.
No, I'm saying if you use your dominant hand, you will have an advantage on
Okay,
decision-making.
okay, yeah.
But that's an empirical question because
Oh, maybe asking for handedness. Yeah, that's
and then do an experiment. You force them down the road. I mean, future. I'm not. You know.
Yeah.
But I think I agree on that. Just like if you force yourself to drive your car back home using the left feet, it will make a difference.
Yeah.
Yeah. Yeah. So it's actually you are adding a factor that it's giving more difficulty. You know, it's like playing like this 7, 3. You know, that's more difficult. Yes, but what's the conclusion of it?
So it might contribute to more of an analysis of the cognitive resources that you're.
Okay, yeah, because if it's demanding, yeah, I'm actually doing like an inhibition.
Sure.
Yeah, I got it now. Yeah, thank you.
Yeah, well, you're welcome.
So,
Couldn't even know.
and this goes to Daniel. The Maya records surface EMG data from the arm wirelessly. Daniel, which is a presidential grant awardee, mission is to decode the EMG traces recorded from one of the players, which is a big mission, and it's kind of complicated. Now, you see, each one of these little sectors contains an EMG recorder, which records the electrical activity that make your muscle move, right? So you're having 8 traces of muscular activity with this thing, right? So this creates patterns of activation, right? So the problem that Daniel is working on now is to understand when a person is playing a 3 and distinguishing from when it's playing a 2, only by reading the data, okay? I just want to summarize what it's doing here. So we know from the videos in this particular example that this is a 3, this is a 5, this is a 4, this is a 5, this is a 5, and this is the accelerometer data, which means that you go down with your strength and then you go up, right? The maximum of acceleration will peak at a certain point, right? And it gives you exactly what kind of portion of the trace you have to look at, right? We have 8 myographers, right? You see how complex is the thing? Now, after doing that, he took out from the games all 4s. For not all the games, but from one game, all 4s. You see that the 4s are more or less noisy, right? But this is a particularly good, oh, wait. These are the 8 myographers. This is very noisy with the 4s, but this is actually good, right? So what Daniel did was to take this myographer data and just work with the 4s and this myographer, right? Are you with me? Okay, good.
Why? The question is why.
I can answer why.
Oh.
Please.
Yeah, the reason why is physiologically your hand and the way the mile is placed is number 4 is all the way up here. And when you flash a 4, your muscles that are contracting are this one, and these are number 7. So 7 should be the one that has the most of the purest sine wave, or no, the electrical signal in that pattern should be the purest for number 7. And let's say for 2 or 1, here you don't have anything here going on. That's why for the one he's highlighting right now, I picked it to be the best one to compare that pattern with the rest of the game, because you can use for number 4. The rest of them they're going to be extremely noisy. Excuse me. Let me show you here. This is a 4, and this is just noise.
Right.
See? This is a 4, and this is just noise too. Too much noise for this one the same. But if you see here, they're cleaner, and this one in particular, because it was after, I don't remember what anymore, it was the cleanest of them all. So that's the one I have been using.
That's exactly what I was going to say. He took this.
Or are you just exploring?
Just, what do you mean by hypothesizing or
Are
exploring?
you just collecting data to explore what happens, or do you actually have an hypothesis related to muscle and brain and all this stuff?
It depends. Right now, I think my hypothesis is if I take that one and the number 7, that right now you check it with the rest of this game or other games, and they're always going to land at number 4 in that crazy thing up here.
Okay, let me.
Yeah.
Okay, now he took the clearest of these patterns, and then now what he did, this is kind of complicated. He took this pattern of numbers, right? Because what we see here is nothing else than a lot of numbers, one after the other, that represent a y value in a configuration. They go up and down, right? Okay. Now, if you play this into this, right, you will have a moment in which this part of the wave will be exactly the same, because it's the part from which the part was taken, right? Let's suppose that I have a very noisy signal, right? Can I write here? It's good, right? Okay. So I have something like this, okay? Now, let's suppose that this was the number 4. Now, if you take the number 4 that is shaped like this, and you move all over the place in this configuration, the total configuration, what you have is that when it arrives here, will overlap perfectly, right? Do you understand me? A little bit?
Can you say that again?
Okay, yeah. Let's do it more clear. Okay, you have something like this, and then you have this kind of behavior, right? Okay. Now, let's suppose that you have this thing isolated. You see? Which is exactly like this. Now, I make this move all over the place, like tiki, 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 tiki. When it arrives here, it will overlap exactly on the top of that. It will have a perfect match with that, right? Now, this perfect match is signaled by something that is called autocorrelation, right? So you will have an enormous peak when, at that moment in which the signal was taken. But you will have also a nice signal also in the other fours. For example, this one is high because it's probably a 4. This one is high because it's probably a 4. It's not the same 4, but it's a 4 because it causes exactly the same kind of movement up and down in the electrical activity, right? Okay, this is what he is doing now, and it's a lot of work. Thank you, Daniel. So, almost done, and then we have probably 5 minutes for questions or something. This is about reported strategies and comments. These are interviews. People report that they read the sequences of the other, especially their hands. They try to change your own sequences. Wins who is faster to understand the sequences of the other. Almost everybody mentioned, oh, this is very weird, I don't know what it means, but almost everybody mentioned rhythm and cadence as a crucial factor. I would say that this is not very important because, you know, you just go the same rhythm, but they say almost everybody, and we have like 30 interviews. Oh, I changed the rhythm, I changed the pace, and I don't understand what does it mean.
Well, maybe it's like a fraction of a second. I mean, maybe they're that sensitive to the pace.
I don't know, yeah, but
Like maybe it seems to us it's all the same, but maybe they can really tell like minute differences in pacing.
maybe if when they slow down, they play a number, and so you understand like unconsciously that the person is going to play something because it changed the rhythm, or I don't know.
That's the bluff and poker.
Yeah.
That's what the fake. That's why people wear sunglasses or put hats on.
But you don't look at the face. You are just looking at the hands. Maybe it can be in the hands.
Hand recognition.
Yeah.
Well, maybe rhythm is associated with their own unique pattern.
Yeah.
That's what I thought.
Yeah.
Deeper
Absolutely.
But I'm very fascinated about this rhythm thing. Everybody's talking about the rhythm.
There's the music piece.
Yeah. And then when you don't know the opponents, you can lose to non-experts. This is why you play 3 times. The first time is to understand the other people. And then the second time you kill them because you know their sequences, right? Then they often report that you need to resist sequence repetition, right? And they often claim not to be fully aware of what they do, which is very fascinating. Now, preliminary considerations, sequences of 2. Preliminary evidence that we have preliminary evidence that sequence repetition is frequent. My question is repeating sequences inevitable? According to the literature, is inevitable. How much people are the same in repeating sequences, or how much can escape from pattern repetition if they are with expertise? We don't know that. So we're going to analyze that. What is the cause of pattern repetition? This is something that's really fascinating. And this is not about Morra game, but why we are so repetitive in number generation. So fascinating. Strategies. All experts target most frequent numbers. All experts try to avoid repetition, and everybody try to read the game, mostly the hand, but some, the most experts, also the voice in combination with the hand. General conclusions. I think that Morra is a valid ecological setting for study aspects of human cognition. Electrophysiology of Morra can help gesture categorization, analysis, and prediction. Not only Morra. This maybe responds your questions about what is your theory, Matt, right? because when you are able to predict pattern configuration of the hand, you can use it in many different ways. For example, also in rehabilitation, or you can use it for gesture control in a car, for example, for interfaces. There are many, many possible applications what Daniel is doing. Okay, the third one is the Morra can be seen as a variant of the RGT, the random generation task. And this is very interesting because it's played. It's not like a neuropsychological test. It's not a psychological test, but it's played, and we have a lot of data about that. And it's natural, and we can work with this data. For example, do the champions have a better working memory? Probably yes. And social, anthropological, and cultural aspects are still to be explored, but I'm very interested in it, and I hope to involve professionals in this very soon. Thank you. Do you have questions? Please, George.
Do you think this will move online? Will people be Skyping, or within that, would that change your data?
Oh, that's
Would you
interesting.
have that extra, extra change in perception and time?
Oh, that's very interesting also to recruit more participants. If you can actually make people play from different parts of the world. Because Skype now is really fast, so you can synchronize it. Yeah, good.
So, is it a cultural thing that only men play this game?
It's not true that only men play the game, but it's the 90%, the 95%.
0.9. There's a study, right?
There are, for example, in Teruel, in Spain, I saw tournaments, they are available in YouTube, in which children play. There is no distinction of gender at all. But I believe that when the testosterone gets high and you are 20, it's something like a brave thing.
There was that woman that you wanted to involve in this.
Oh, yeah.
I completely forgot about this woman. And the guys were all like, oh, don't call her, she's crazy. She'll ruin the whole thing. She'll just contest every point, just don't call her.
Yeah.
I mean, it was really scary.
This is anecdotal knowledge about this single women champion that we have in Sardinia. There is only one, and he beats everybody. So this is a good proof that there is no difference in mind, but definitely there is difference in the social and anthropological aspects. Now, there was a study in the 60s, it's an anthropological study that analyzed the posture of playing Morra. And it's like always all the body is rigid, and you do this, right? And you don't move the hands, the legs, and it's really like, I don't know. It's like a physical fight, simulation of it, right? It's really, so this can be an aspect of it. Chamak.
Do you have any data that shows, I guess, when they fell into patterns? So kind of like, would it show a shift in thought processes where maybe at first they were just putting out numbers and so they didn't really have any pattern, it was more random, and then they started focusing on the other player?
Yeah.
Then like they started showing patterns because they were more focused on picking their patterns?
Right. It's very difficult to distinguish when you are following the others and you are doing your own pattern, because you just have recordings. Maybe if we would have like EEG recordings, would be easier, but if you move your body, then the EEG recording is going to be very messed up. But there are excellent mathematical tools that we can use to see how much and how often and when you go into patterns. Like this one, which is, it's a paper that I'm just analyzing. So we are working on it.
So I would think it would be kind of when you're cognizantly changing the numbers or thinking about the numbers you're putting down, and then when you leave it to autonomous and you're more focused on the other player, then that's when the patterns arise.
So you are saying that there is a trade-off between the attention to what the other is playing and falling into patterns. Very interesting, and we can have a mathematical analysis of it. When you do, maybe when you are going into patterns with your hands more, you are targeting more the numbers of the other, like a correlation of this kind. Very interesting, Jamaica. Yeah.
I think we're
Paul.
on time. So let's
Okay.
thank Franco for this talk.
Thank you.
Please come next month, on March 14th, to hear about the Flint water crisis. Thanks for coming. We have a professor from Henry.
Hey.
Politics